All right. So good morning. As the subject is especially histological techniques, including immune chemistry and molecular pathology, and the subject code is 21 MSH. And currently we are in the unit 2 actually. Okay, we bypassed unit 1. Unit 1 we will discuss this soon. So according to the unit 2, we have all the core immunohistochemistry techniques like fixation, then antigen retrieval, blocking of endogenous enzymes, blocking of non-specific sites, then staining with the help of these primary, secondary antibodies, and there are different methods of staining procedures. So all these things has been discussed in the unit 2. So currently we are discussing about unit 2, which is immunohistochemistry. So far, a quick revision. So for past few week, for last week we discussed about the definition of immunohistochemistry. Then we discussed about the uses of immunohistochemistry. Then we discussed about their applications. Then we discussed about the general protocols of immunohistochemistry. So the general protocols of immunohistochemistry includes tissue preparation, pre-treatment, and staining. Tissue preparation includes fixation, section, mount preparation. Then in the pre-treatment, we discussed about antigen retrieval, endogenous enzymes inhibition, and blocking of non-specific sites within the tissue. Then the third part will be the staining. So in the staining, we will go with the classical antigen antibody mediated stainings. Still, there are many methods of staining protocols that I will discuss. Okay, so as of now, we have finished the first part of the immunohistochemistry, which is the fixation. So we discussed everything about the fixation. Now in today's lecture, we will discuss in detail about the antigen retrieval. Okay, the part 2, which is the antigen retrieval in immunohistochemistry. Okay, then I will also discuss about a brief summary of this whole immunohistochemistry in a new way with diagrammatically. Okay, so yeah, so we already discussed about the importance of fixation, their principles, all these things, right? And then anyway, so I'm just skipping this fixation part. And we discussed briefly on specialized fixation techniques like spray fixations, vapor fixations, and this freeze drying. Okay, we discussed all of these things, their types, classifications, target tissue, and their fixators, everything. Okay, then there are advantages and disadvantages of these fixations. Okay, and then the second step, as we know that the second step in immunohistochemistry will be the antigen retrieval or pre-treatment. That includes antigen retrieval, endogenous enzymes blocking, and blocking of non-specific enzyme sites of the tissue. So now coming to the antigen retrieval. So before discussing about antigen retrieval, I would like you to tell few things. Let me take a highlighter. So I'm going to take highlighter here. Okay, so here students, we have a tissue. So this is a tissue. Okay, so this tissue has in immunohistochemistry, we are trying to locate the antigens. Say for example, these are antigens. Okay, so these are antigens. So these antigens need to be stained. These antigens need to be detected. But what we did to this tissue, now we subjected this tissue to I will write here. Okay, we subjected this tissue to fixation. So we subjected tissue to fixation. Because of this fixation, what happened? There is a cross-link formation among the antigens. So among the antigens, cross-link formed. Because of this cross-link formations, okay, protein cross-links, the antigens has been masked. The antigens has been embedded deep into the tissue. So because of this masking of antigens, because of these cross-links, our antibodies cannot able to bind to the surface of the antigen. That is the major problem with fixation. Now, what we need to do is, now we need to remove these cross-links from the tissue. So this is tissue, we have antigens, and now we got the cross-links. Now we need to remove these cross-links. Okay, how to remove these cross-links? And this particular step is called as antigen retrieval. Okay, antigen retrieval. RETRI. Okay, I'm unable to write properly. So antigen retrieval. So in this antigen retrieval, somehow we are trying to remove these cross-links. So I will show the cross-links with another color. Okay, so yeah, so there are protein cross-links among the antigens. So now these protein cross-links need to be removed. Okay, so there are few traditional approaches of removing this protein cross-links. Okay, so the first technique is by using some enzymes. Okay, before that, Are you seeing what I'm drawing on the screen, students? Can you able to see this whiteboard? You can see it, right? Students, are you following me? Just for confirmation. Are you following me, students? Can you see this whiteboard, everyone? Are you listening, students? Yeah, I got, yes, Damini, thank you. Okay. As
Yes,
we
sir.
Yes, thank you. See, now we got antigens, and this antigens has crosslinks. Now our idea is to remove these crosslinks, and removing these crosslinks among the antigen is called as antigen retrieval. By the way, students, I want to tell a few things, one important term. See, the part of the antigen that binds with an antibody, this part of antigen binds with antibody, right? This part is called as epitope. Epitope. Keep in mind, the part of the antigen that binds with antibody, this particular part is called epitope. That is why this step is also called as epitope retrieval. They are also saying this as a epitope retrieval. Okay, epitope, we can say it as an antigen. The part of antigen that binds with an antibody is called as epitope. Okay, hence this technique, this part is also called epitope retrieval. Okay, epitope retrieval. Okay, now as I stated, we need to remove these crosslinks. In order to remove these crosslinks, we have many approaches. One is I can use some digestive enzymes, protein digesting enzymes. Okay, I'm drawing enzyme like this. Okay, by using enzymes, I can able to remove these crosslinks so that the epitope will get uncovered. Epitope will become surface. Okay, so that we can be able to bind antibodies to this epitope. Okay, so the first technique will be by using some enzymes. Okay, enzymes like proteases, the enzymes that will cleave the proteins or the crosslinks. So here the crosslinks is formed due to polypeptides, which is due to collagen crosslinks. Okay, so the collagen enzymes can be used for removing those collagens. Okay, proteases, such as we can use trypsin, chymotrypsin, then proteases. So all enzymes that can able to cleave the proteins, such enzymes can be used to remove these crosslinks. Or we can also use second technique, which is heating technique. Okay, second technique will be heating technique. So the idea is very simple. We know that by heating we can able to destroy we can able to coagulate the proteins. Now we are trying to with the help of heating, we are trying to destroy this crosslinks. But I know when we are trying to heat, that not only denatures the crosslink proteins, but that can also damage the antigens, because we know that antigens are also proteins. That is one problem with the heat antigen retrieval. That is why we have a very clear, very clever approach for this problem. Say, for example, this is unfixed protein, fixed protein. I induced heat. So, okay, fixed protein has crosslinks. So it has some crosslinks. Okay, these are crosslinks. Now I'm subjecting it to the heat. So I subjected it to heat. Because of heat, crosslinks will become one part, and a protein will become one part. But this protein is in not good shape. Okay, now we got two parts. This crosslinks, Cl crosslinks, and we got antigen. But this antigen is not in the right shape. Now, this antigen can bring back to the right shape by adjusting the pH. By adjusting the pH of this tissue, these antigens will get their original shape. The proteins will get their original shape. So this is how the heat inducing technique will occur. So by heating, obviously we are denaturing the proteins. Then we got two types of proteins. We need not to worry about this one, but the antigen need to be formed into its original shape. That original shape antigen can be achieved with the help of adjusting the pH, depending upon the type of antigen that we need to retrieve. According to that antigen, we need to adjust the pH. Okay, by adjusting the pH, we can able to get the original shape of the antigen that we want. Okay, now there are many methods of inducing heat into the tissues. One method will be very simple method, which is by using microwaves. So by microwaving, you can able to induce heat and you can able to remove. But microwave, okay, one is microwaving, but microwaving has some problem. The problem with microwaving is when we are subjecting microwave heat to the tissue, it will cause heat and cold spots in the tissue. The heat won't be spread evenly in the tissue. Some part of the tissue will be very hot and some part of the tissue will be very less hot. And we also need to mind that excessive heating may destroy the tissue. So we need to mind that there is no excessive heat spots in the tissue. So microwaving is not a ideal method of inducing heat into the tissue. So we need some modified heat inducing technique. So the second modified technique is by using pressure cooker. Just like the way we are using autoclave, we can able to use pressure cooker to induce heat, and this pressure cooker can able to remove the crosslinks among the tissues. Okay, but still pressure cooker is safer than microwaving, but still pressure cooker has its own disadvantages. Excessive heating with pressure cooker or fluctuations in the pressure of the pressure cooker can lead to damaging of actual antigens also. So in order to compensate this problem, now we have a modified technique called pressure cooker plus enzyme method. So we are using both pressure cooker and enzymes, okay, for removal of these crosslinks from the tissue. So this is the third technique. Third technique will be a pressure cooker with enzymes. Okay. Then nowadays commercially we are getting certain reagents that can directly able to remove the crosslinks. So now we have even these reagents are available. So readily available reagents are available for removing crosslinks, okay, for antigen retrieval. So now this particular step classically is called as this heat induced crosslink removal is also called as HIER. This particular method is also called as HIER method. So what is this HIER stands for? HIER stands for heat induced epitope retrieval. I said, right, the part of antigen that binds with antibody is called epitope. So since in order to retrieve the epitope, since we are using microwaves or heat, hence this technique is called as heat induced epitope retrieval. So these are the methods we are going to discuss in the next few minutes of this lecture. So far we discussed about fixation in last week, the importance of fixation of tissue. And today's lecture we are discussing about how to retrieve our antigens from the tissue. So this antigen retrieval can be done with the help of either by using specialized enzymes or with the help of some heating techniques we can able to retrieve the antigens. So enzymes such as chymotrypsin, trypsin, proteinases can be used, whereas heating techniques we can use microwaving, pressure cookers, autoclaves, pressure cooker with enzymes, or even we can use specialized solutions, solutions that can able to remove these crosslinks among the antigens. Okay, so let us see the notes of this antigen retrieval. So manual methods for antigen retrieval or antigen unmasking include proteolytic enzyme digestion. By using some protein digesting enzymes, we can able to remove the crosslinks among the tissues, or by using microwaving, we can able to remove the crosslinks, or by combining microwaving with some enzymes, we can able to remove the crosslinks among the tissue. By using pressure cooker, we can remove the crosslinks. Then there is a modified pressure cooker with enzymes that can be used. We can use autoclave. Yes, we can also use steam. Just subject the tissue on the steam. Okay, on the heat steam. So by subjecting it to the steam, we can able to remove the crosslinks among the proteins. And obviously, we can use water bath. Water bath is the most safest method of removing crosslinks from the tissue, or method of antigen retrieval. Okay, water bath we already know. So at room temperature, we will maintain 37 degrees centigrade room temperature, and we will suspend the tissue for next 2 hours. So by subjecting it to this water bath, we can able to remove the cross links among the tissue. So this is the idea of water bathing. Okay, so these are the methods of unmasking the antigens or antigen retrieval by using specialized enzymes, microwaving, combined microwaving enzyme method, pressure cooking, autoclaves, water baths, or even steam can be used as a tools for antigen retrieval. Okay, so these are the methods of antigen retrieval. And the same story I have given as a notes in the next coming slides. Say, for example, proteolytic enzyme digestion. So in this technique is described by one scientist in 1976. So the enzymes that we are using for this digestion purpose are trypsins, proteases, chymotrypsins, pronases, and proteinase K and pepsin can be used as a enzymes of choice for digesting the crosslinks among the epitopes. Okay, so this is all about enzyme digestion. There are still some disadvantages of this proteolytic enzyme digestion. The disadvantages are sometimes undigestion can happen. Not all enzymes are active at removing the crosslinks. So undigestion is one problem with enzyme digestion. And other one is overdigestion. Enzymes not only digest the crosslinks, but enzymes will also destroy the actual tissue. And these enzymes will even damage the antigens and epitopes of the tissue. So these are some disadvantages of using enzymes as a part of antigen retrieval. Okay, so this is all about the enzymes as a enzyme digestion. Okay, enzymes in antigen retrieval. Then the same diagrammatic representation. The crosslinks will be removed by proteolytic enzymes. Proteolytic enzymes will remove the crosslinks. Then second one, heat-induced antigen retrieval techniques. So here, heat-induced antigen retrieval, HIER. So in heat-induced antigen retrieval techniques, what is the idea? So we will keep some heat. So the proteins will coagulate. Now this coagulated proteins will be in two forms. The crosslinks, removed crossing protein, we need not worry, but the protein become in another form, another shape. Now we need to retrieve the actual shape of the protein. That can be achieved by subjecting the protein or the tissue to the specific pH. So I will show you in a diagrammatic way. See here. So fixed, then we heated. Because of heating, the tissue proteins has been unfolded. So the tissue proteins has been unfolded. Now, in order to facilitate refolding of antigen or epitopes, now we will cool the antigen. Not only cooling, but also we will ensure to subject it to various pH. Okay, at different pH, different proteins will refold into their actual shapes. Okay, so in cooling and by maintaining various optimum pHs, we can able to bring back the original shape of the tissue or original shape of the antigen that we want to detect. Okay, so this step is very important. So in antigen retrieval, not only heating, upon heating, we must subject the tissue to certain pH variations. We need to cool down the tissue. That cooling down need to be performed under the some optimum pH conditions. Okay, like 9, 4.5. That depends upon the type of antigen we are using. Okay, and I said right, we have various approaches of doing this HIER, heat-induced epitope retrieval. We can use microwaves, we can use pressure cookers, we can use a steam, or we can also use water bath for the purpose of this antigen retrieval. Okay, same stories. So we can use a microwave. So after microwaving, see, we are using this citric buffer, so to maintain the pH. Okay, so this pH maintenance, we need to subject the pH variations to get the actual shape of the protein. So this is a microwaving. There are many problems with microwaving. A few problems with microwaving is production of hot spots within the tissue. This is the disadvantage of microwaving. So it will produce hot spots, and that hot spots will boil. So they will destroy the tissue. So microwaving won't disseminate the temperature evenly within the tissue. Because of this improper or uneven distribution of heat, there will be obviously problems. So microwaving is not an ideal choice. Then we opted with a second approach, which is the pressure cooker approach. So here we are using pressure cookers as an ideal thing. So just like an autoclave. Okay, So we need to maintain the pressure of 15 psi, and at 120 degrees centigrade, the proteins will unfold and they will be subjected to pH variations to get the refolding of proteins. So this is a pressure cooker, but pressure cooker has its own disadvantages. Like not all high temperatures can cause a complete irreversible damage to the tissue. So uh, in order to overcome that problem, then we have another modified technique called pressure cooker with enzymes. Okay, pressure cooker with enzymes can able to recover the problem we faced purely with the sole pressure cooker retrieval technique. Then the third technique is steam technique. So steam is very ideal compared to the previous two techniques. So by subjecting the tissue to the steams, there will be the minimal damage to the tissue. So minimal damage can occur to the tissue, and it is most efficient form of antigen retrieval technique compared to the previous two techniques. Okay, then there is even more safer technique, which is water bath. So water bath is the uh, uh, best technique for antigen retrieval. But the backlog, the disadvantage with this water bath is time. We need to subject the tissue for prolonged long periods of time in order to achieve antigen retrieval. Okay, but water bath is the safest procedure of antigen retrieval. Okay, so this is all about the all about the antigen retrieval step in the immunohistochemistry. Okay, as I stated, there are combined microwave antigen and trypsin enzyme digestions. So there are many advantages of these techniques. Okay, so yes, there are obviously few disadvantages of this heating. Okay, antigen retrieval. Overheating or less heating can permanently damage the tissue. If the tissue permanently damaged, then it will be a real challenge to get another biopsy from the patient. Okay, patient is not ready to undergo repeated surgeries just for the diagnosis. Okay, so all sections are precious. So the steps that we are going in the immunohistochemistry need to be very cautious. Okay, these are sensitive techniques because the sample is very limited to us. It's not blood or urine sample to collect again and again from the patient. Okay, so we need to be very careful when we are doing the tests. We should not damage the tissue, or we should not encourage such misconducts during the performance of this test. Okay, so as I stated, nowadays we are getting this commercial antigen retrieval solutions also. So we have like citrate buffer at pH 6.0, EDTA buffers, vaccine reagents, and TRIS HL. Okay, TRIS buffer solutions. Usually it is called TRIS buffer solution, which is TRIS HCl buffer solution, is also available commercially for the sake of antigen retrieval. Okay, so this is all about the antigen retrieval step in immunohistochemistry. So a quick revision of antigen retrieval. So as we know that the immunohistochemistry has three parts: tissue preparation, pre-treatment, and staining. In tissue preparation, we have fixation. Fixation will cause cross-links among the antigens, and now we need to remove those cross-links, and that is the second part of the immunohistochemistry, which is the pre-treatment. So in the pre-treatment, we have antigen retrieval, blocking of endogenous enzymes, and blocking of non-specific sites. So antigen retrieval can be achieved either by using enzymes or by using heat-induced techniques. So antigen retrieval, as I stated, so cross-links will be removed either by enzymes or by heating. Heating can be microwaving, steaming, then pressure cooker, autoclaving, or even water bath can be used as a techniques for retrieving the antigens. Then we will subject it to the various pH variations to get the actual shape of the protein. Okay, proteolytic enzyme, microwaving, combined pressure cooker, all these things. Okay, and also don't forget about this step. Upon heating, the protein is in another form, unfolded form. Now, in order to refold the protein, we need to cool down, and in this refolding must be done in the presence of some pH, optimum pH conditions, to get the actual shape of the antigen that we want. So this is all about the antigen retrieval. Okay, all right. Now, let us go back to this step. So far, we discussed about antigen retrieval. Any doubts in antigen retrieval, students? Is everyone following? Is there any issues? Is there any confusions so far in this lecture? Are you following everyone? Jaspinder, Ishdeep, Damini, Deepika, Alexis. Okay. What I want to ask is, can I proceed today or shall we? No issues. Thank you, Preeti. So okay, in tomorrow's lecture I will discuss about inhibition of endogenous tissue components. Okay, so maybe I will discuss in detail in tomorrow, but I would like to give you an overview of this entire immunohistochemistry in the coming slide. Okay, so kindly mind, pay attention. Let me take one empty slide. See here. So first we got a tissue, and tissue has been fixed. Okay, it is subjected to fixation. Fixation caused a problem with the fixation caused crosslinks. They formed crosslinks. Now this crosslinks has been removed by antigen retrieval. This crosslinks has been removed by antigen retrieval, right? Antigen retrieval. Now I will show you here what happens in the tissue. So this is tissue. Okay, then we did antigen retrieval so that the epitopes has been exposed. The masked epitopes has been unmasked. So the epitopes has been unmasked in the tissue. Okay. Now to this tissue, I will tell you traditional approach. Then I will tell the problems. Wait, let me take another color. To this tissue, my idea is I will bind the specific antigen with the help of a specific antibody. If this antigen is CD4 antigen, if it is CD4 antigen in the white blood cell, I will target this CD4 antigen with the help of anti-CD4 antibody. With the help of anti-CD4 antibody, I can able to bind. Okay, but the problem is antibodies are also non-color or colorless components. If they are colorless components, I cannot visualize these antibodies. That is why I will label this antibody with an enzyme. Okay, say for example, I will conjugate it with an enzyme like peroxidase. So this is peroxidase enzyme. Okay, PX. Okay, peroxidase is an enzyme which is conjugated with this antibody, anti-CD4 antibody. Okay, there is one more problem. Even though I conjugated this antibody with peroxidase, but still I can't able to detect this peroxidase. In order to detect this peroxidase, what I will do is I will add a chromogen. Chromogen such as DAB, diamino benzamin. I will add a chromogen which is DAB reagent, diamino benzamin reagent. Now this is called chromogen. Okay, CHR chromogen. Now this chromogen will bind with peroxidase, and this will give yellow color, brownish or yellow color. So production of yellow color indicates that positive for presence of corresponding antigen in the tissue. This is the classical approach of immunohistochemistry. So here there is involvement of two important things or three important things. One is antibodies, second one is conjugates that will bind to the antibody, and third one is coloring agents such as DAB, diamino benjamin. Okay, these are the three components in the staining part of immunohistochemistry. But there is a problem. There are two problems. So I'm going to write the two problems. The first problem is if this tissue is a highly energetic, such as if this tissue is a prostate gland, if it is a prostate biopsy, the problem with prostate biopsy is prostate gland tissue has so much peroxidases within the tissue. This is one problem. See, if it has so many peroxidases in the tissue. Okay, now the problem with this peroxidase is, see, in my reagent, in my stats, I'm binding this antibody with a peroxidase enzyme. I'm using this enzyme as a target for my chromosome. Now let me show you one thing here. So here, this tissue don't have CD4 antigen. Tissue don't have antigen. Okay, so I'm keeping red here. So there is no antigen in this prostate tissue. But this prostate gland has peroxidase. So what I will assume is, since there is no antibody, okay, this is negative for this antigen. So what I will do, I will buy first I will add primary antibodies. Antibodies won't bind. Okay, antibody with peroxidase, they won't bind to the tissue. Okay, even though they didn't bind it, still, since there is an peroxidase in the tissue, upon adding anti-peroxidase, okay, upon adding chromogen or anti-peroxidase, okay, DAB, or we also have something called anti-peroxidase, AP. I'm writing AP here. Okay, if I use DAB or anti-peroxidase, it will give color. It will react with the peroxidase present in the tissue and it will give false positive to me. It will give false positive result to my test. This is the problem. That is why we must block endogenous tissue inside enzymes. We need to block the endogenous enzyme activity. So that is why we have one important step, okay, which is the blocking of endogenous enzymes. Okay, I don't know why I'm getting this one. Just a second. Okay, so blocking of endogenous enzymes. So blocking of endogenous enzymes can be done by adding certain blockers. So those blockers will block these enzymes. And second problem we have is we may have two antigens. Yeah, it got some problems, students. It's overlaid on this. One second. The second problem will be, see, there is one more protein on the tissue. Say for example, the second antigen is CD5, CD4 4.5. Okay, second antigen is CD4.5. Now I need only CD4 antigen. I don't want involvement of CD4.5 antigen in my test, but my antibodies may bind to CD4.5 also because of their similar resemblance. Since both CD4 and CD4.5 looking very similar, sometimes non-specific antibody binding may happen. Off-target non-specific antibody binding may happen because of their similarity, because the antigen similarity. Antibodies may cross-react with unwanted antigens in the tissue. So in order to prevent this problem, in order to prevent unwanted binding of antibodies to the non-specific antigen, we need to block this non-specific antigens in the tissue. Okay, we must block this non-specific antigens. Only upon these two procedures, we should move forward for staining. Okay, that is why before staining, we must block the endogenous enzymes and we must block the non-specific antigens. So these two we can do. How we will block endogenous enzymes and how we will block non-specific sites will be discussed in tomorrow's lecture. Okay, so this is all about today's session. So I hope you got some idea about what is immunohistochemistry. Do you understood this concept, students? Why we are blocking endogenous enzymes and why we are blocking non-specific sites? Right? Any doubts in today's lecture? No doubts, right? Can I end this session? Yes, students. So, okay, this is all about today's session. In tomorrow, we will discuss about inhibition of endogenous enzymes and blocking of non-specific sites.